This video is about nothing, or rather the absence of something. Hi and welcome back. Today we're going to be talking about Null and Nullable. I'm going to be giving you some tips on where and how to use them. And this is the latest in my video on robust module design, a link to which I will put up here. Before we dive in, if you do like these videos, please give us a subscribe to the channel. It'd be much appreciated. So what are we going to talk about today? First of all, we're going to be looking at what is null. We're going to be looking at how to use nulls, especially in conditions. And then a bit more of an advanced use case in terms of how to use nulls in conditions where you don't know the value until after apply, such as resource IDs coming in and things like that. Then we're going to move on to nullable. How can nullable help simplify the logic in your module? And if you're unsure about whether you should use nullable or not, I have a golden rule that you can use to make your decision for you. So let's dive in. So what is null? Null is, as defined by hashicorp in their docs, there is one special value that has no type. We'll see. A null value represents an absence or omission. If you set an argument of a resource to be null, Terraform behaves as though you had completely omitted it. It will use the argument's default value if it has one, or raise an error if the argument is mandatory. Null is most useful in conditional expressions, so you can dynamically omit an argument if a condition isn't met. So yeah, we use nulls a lot. We're going to look at how to use them in ternary expressions to conditionally create resources and things like that. Really common. However, I do take a slight issue with hashicorp's definition there, because in the work that I do writing code, especially around like linting rules and providers and stuff, null values do have an underlying type. So if we look here, we can see the null val function, which takes one parameter of the type, and you have to supply a type to that null val. So it can be a null value of a string or a null value of a object or whatever. Nevertheless, it does need a type. Now, quite often people will use the underlying dynamic type for this, but still, null values have a type. Sorry, bit of a chip on my shoulder about that one. By the way, the thing that was on the screen just then is from the CTI package, so the CTY package that Terraform uses for its type handling system under the hood. So let's have a look now at how we can dive into the code and see some examples of how we can use null, starting off with something quite simple, and then moving on to a more advanced case where we need to pass in a dependency, but we don't know what that dependency is till after apply. For example, an Azure resource ID, but we still need to conditionally create the resource. So yeah, let's have a look at that and see how it goes. So here we are with a really, really simple example to start with. As ever with me, there is a little problem, a little hiccup that you might encounter, and then we'll come on to that in a second. So we have a variable called myDependency. It is of type string, and the default is null. Based upon that variable, we have a resource called condition, and we're using a ternary expression here. So I'm sure you know what these are, but for those that don't, you have an expression, so something that evaluates to either true or false, and then you if that expression is true, the count will be 1. If the expression is false, the count will be 0. Ternary notations used in quite a lot of programming languages. So yeah, var myDependency is not equal to null. Well, the default is null, so the default then will be 0, so it won't create this resource. So if I go to my terminal, and I type Terraform plan, there is nothing to do, okay? However, if I change this to a value, doesn't really matter what it is, make Terraform plan there, it says it's going to create that resource, and it's the 0 index of it because we're using count. Cool, that's what you would expect, right? Of course, is there a problem? Of course there's a problem. The problem is, if we look in my well-named problem directory, the problem is where we want to pass in a resource ID, say, and that resource ID is not known until after apply. So what happens then? So we've got our trusty Terraform data resource here, and this has got one input and one output. The input I'm just setting to a constant here. The output is calculated, so it's only known after apply. And I'm feeding that in to my module here, which I've called test, and I'm sourcing from the parent directory. And this is really common. So what happens here? So let's go cd problem and Terraform plan. Problem is that the count value depends on resource attributes that cannot be determined until after apply. So in for each and count, you cannot have values at the moment that are only known and before apply time. So what do? Well, what we actually do is change the input schema slightly, because we still want to have the condition. So we still want to be able to test for null, because it's a really, really easy way of creating that resource or not. So let's go back to our null condition here, and let's change this object, and let's call it resource ID, what it is. Okay, so now what we've got is my dependency is an object with resource ID equals string. What that enables us to do is test whether the object is null or not, but we can still input the resource ID into here, even though it's not known until after apply. So it's a really, really nice pattern to use, and let's demonstrate how we might do that. So obviously this would be a breaking change to your module if you are making changes, but I'm hoping that by you listening to this now and learning that you can implement this to start with and not make these mistakes. So if we go back into our problem, what we need to do now is to change this, because this is now an object. So, and it's going to be resource ID equals resource ID. Okay. So that, sorry, that's not right. It's here, my dependency. That's the issue. So it's in there. There you go. So now what I've done is I've wrapped the unknown value inside this object, but Terraform is able to understand that the object itself is not null. The object has something in it, it just doesn't know what it is yet. And that sorts our problem out, because I think what we'll find now is that. There you go. So this is the dependent resource from the root module. It's going to create that. Output is known after apply. It's then going to create the conditional resource, because it knows that the object is not null. It just doesn't know what's inside the object yet. And you can see here that the input is known after apply. And that will work. So that's the first pattern that I want people to remember is if you're going to be passing in stuff that's not known till after apply, like Azure resource IDs, you can't use them in conditions. Well, you can, but it won't be a robust design. It will fail, like you've just seen here. Now, this is a tricky one as well, because what tends to happen is that if you develop your module in an iterative fashion, sometimes you'll be going Terraform, apply, and you're checking things, and then you add this condition in, and it's still fine because you've created the dependent resource before. So it exists, so it knows what that resource ID is. So when you're developing your modules, always do a destroy and apply to fully test it. And obviously an automated test framework can help with this. So yeah, lesson 1, wrap your unknown values in an object, which could then be tested for null if that pattern applies to you. Okay, let's now move on to Nullable. Okay, here we are again. You can see that we have another common scenario where you are creating a resource with a for each. So we've got a variable called foos. It's like how many foos do you want? And it's going to do a for each. And that's a map of an object with the string foo inside it. So yeah, pretty common, simple example. The default that I've given it is an empty object. So that empty map, sorry, not empty object, but essentially this is a map of objects and then it's empty. So when this evaluates, it will be empty and you'll get no foos. This is exactly what we want. So just to prove that, there you go, Terraform plan, no foos. But what happens if some unsuspecting consumer of your module supplies null in here? That happens. So can't do it because it can't do a for each on a null value. So what do? Well, what some people do is this. We go, okay, var foos is, Copilot's way ahead of me as usual. If var foos is not equal to null, then var foos. If not, give me the empty. So that's fine, and it works, as you'll see. That works, no foos. But it's a bit rubbish, isn't it? It's harder to read. It's harder to understand. If only there was a simpler way. Guess what? There's a simpler way. What we need to do is put that back and put nullable is false in there. So the default value for nullable is true. So you don't need to set it. It's in fact, you shouldn't set it really. What this will do is if someone tries to pass null into here, Terraform will give them an error. Say, no, it can't be null. It must be something else. So what we that is a really common pattern. Default empty map, nullable is false, is a really, really robust way of designing these things. But as we know, null has a meaning. Null means I don't want this. So when is a good rule for when I should set nullable on my variable or not? So the trick is, if you want a golden rule to know when you should use nullable or not, ask yourself this. Is there a semantic difference between a null value and an empty map or an empty collection? Quite often when you're doing for each with a map of object, you'll find that there is actually no semantic difference. So there's no meaningful difference between a null value, because a null value would indicate that I don't want any foos in this thing. That's fair. And an empty map would also indicate that I don't want any foos. So there's no difference between the two. So to save yourself trouble of unnecessary ternary expressions, you should set nullable in these values to be false. And that will mean that the default value is empty and the caller can only supply either an empty map or a map filled with objects. So yeah, I hope that helps. So there we have it. That is null and nullable. So what did we learn? That null is the absence of a value, even though underlying it still has a type. And that null is typically used in conditions. So if you pass something into your module which has a null value, you can use that null value to determine if you do something or not using count. We also learned that sometimes passing in values that aren't known till after apply, that is then problematic. So the way to get around that is to wrap that in an object. So the unknown value is an attribute of your object, but you can still test for the object being null or not. Finally, we looked at nullable, and we learned that for collection values, when you're using for each, so maps of objects, then using nullable is normally a good idea because there's no semantic difference between an empty map and a null value. You still means you don't want any of the things. However, for other values, the golden rule for nullable is there a semantic difference between a null value and an empty value? So for primitive types, it's typically not normal to set nullable equals false, because there is definitely a difference between an empty string and a null string. And there's definitely a difference between a zero number and a null number. So yeah, I really hope that's useful. As ever, if you have liked the content, please click on that subscribe button, and a like would be much appreciated as well. I will see you next time.